So a useful tool that we have in section 9.1, we have the absolute value theorem. This simply states that if the limit as n goes to infinity of a sub n inside of absolute value goes to 0, then the limit as n goes to infinity of a sub n is also 0. So one handy little tool. So basically, in other words, if there's alternating signs, if we sort of temporarily neglect the alternating signs and just see that, okay, neglecting the signs, this goes to 0, then in the original, we will also head to 0 as n goes to infinity. Some more handy tools. -1 to any power is just something that will alternate signs. So just flipping positive, negative forever. Some other common series, 2 to the n. So that'll just give you outputs 2, 4, 8, 16, 32, 64, and so on. 3 to the n. 3 to the first 3, 3 squared 9, 3 cubed 27, 3 to the fourth 81, 3 to the fifth 243, etc. Factorials and factorial. We'll start at 1 here. Remember, if we do include a 0, 0 factorial is defined to be 1 as well. 2 factorial, 2 times 1 is just 2. 3 factorial, 3 by 2 by 1 is 6. 4 factorial, 4 by 3 by 2 by 1, 24, and so on. So buck 20, 720, etc. 2n quantity factorial. So if n is 1, 2 by 1 is 1, 1 factorial is still 1. If n is 2, 2 by 2, 4, and 4 factorial is 24. 3, 3 by 2 is 6, 6 factorial, 720, and so on. So that one, as you can see, grows quite fast. So those are just some helpful sequences to know as we're going forward in Chapter 9. Next we look at some more definitions. We'll start with monotonic. So a sub 1 is at least a sub 2, which is at least a sub 3, which is at least a sub 4, and so on. So this one would be a monotonic non-increasing sequence. So it might stay the same or it might drop, but it does not increase. And you can make a similar definition for a non-decreasing sequence. Just flip the signs. I also want to talk about bounds. Sequence is bounded above if a sub n is less than or equal to m. M is some element in the reals for all n. M is an upper bound. So in other words, once we get past whatever nth term, all of the other terms are less than or equal to some constant m. You should also be able to construct for yourself a good definition for something that is bounded below. So I'll leave a little gap there, let you try that, and then we'll talk about a bounded sequence. So a sequence is bounded if it is bounded above and below. So in other words, we have to have a lower bound and an upper bound. If it's trapped between those two values, it is a bounded sequence. And one consequence that we get from marrying those last two ideas together with the monotonic and bounded if it is both of those things, then it converges. So the idea is if it's bounded, we're trapped above and below. If it's monotonic, it's always either staying the same or increasing. We can do a similar one for if it's decreasing. So it's always either staying the same or moving up, but it can't move up past this upper bound. It has to approach that upper bound, or if it stays the same entirely throughout, again, it's still going to converge to that one point where it is staying the same. The fact that it's monotonic says that it can't bounce back and change direction. So it is going to then head towards one point. If it's not bounded and it is monotonic, if it's not bounded above, it can still diverge. It would just keep going, for example, up forever or down forever if we look at it the other way. All right, so we'll look at sequence A sub n, 5 over 1 plus n. Okay, so this is a bounded sequence. The max this can reach is 5/2. If n is 1, 5 over 2, that's the biggest this can be. And this is bounded below by 0. If we take the limit as n goes to infinity, 5 over 1 plus n, numerator is constant, denominator grows without bounds, we approach 0. So we're bounded by 0 and 5/2. And the bigger this denominator gets, the smaller the value gets. So this is also monotonic. So this one converges. B sub n, we'll try 5n over 152. This is monotonic. Every time n increases, B sub n will also increase. We're bounded below by 5 over 152. However, we're not bounded above. As n goes to infinity, 5n over 152 also goes to infinity. So we cannot guarantee that this will converge. One more that I want to look at in this concept. We'll call this, not so creatively, C sub n. -1 to the n plus 1 power. So this one is definitely bounded. You should see the highest this can reach is a +1 as long as n is an odd number. Odd plus an odd is an even. -1 to an even is 1. So it's bounded above by 1. Bounded below by -1. However, this is not monotonic. If we just do the first three elements of this sequence, we can see that. When n is equal to 1, odd plus an odd is an even. -1 to an even power is 1. N equals 2. Even plus an odd is an odd. -1 quantity raised to an odd power is -1. So we're decreasing, but as soon as we go to 3, now we have -1 quantity raised to the 4th. We're back to +1. So we went down, then we went back up. This is not monotonic. So we're bounded, but not monotonic on that one. Okay, so from section 9.1, you should be able to try out 1 to 13, the odds, 19 through 22 all, 23 to 39 odd, and 45 to 97 odd as well. If you have any trouble, please get in touch with me. Otherwise, I'll see you for 9.2.